I have rescheduled your oral exam date and time. I upload the date and time in the Google Classroom. So all of you check your date and time according to your serial. Do you clear, guys?
Yes, ma'am.
Yes, ma'am.
Okay. So previously we learned the two algorithm. First come first serve, and second one is short job next. Two types of scheduling. Both of them are non-primitive. So at the two types of scheduling, there was no interrupt occur or there was no suspension occur. But today the scheduling we're gonna learn about that is shortest remaining time scheduling. So whenever we learn the shortest remaining time scheduling, it is actually follow the suspension. It not only follow the timing, but also whenever inside the timing, it find out some priority tasks at that point of time, it stop the user tasks and go for the priority tasks. So at first, let's see the mathematical calculation for this algorithm. Okay. So first look at here. There are total four processes. Process 1, process 2, process 3, process 4. Then look at the arrival time. So at 0, the first process is arrive. So whenever the first process is arrive, see, okay, at first let me draw it for you. So it will be helpful to understand. So total four process. So you see, and when arrival time is 0, at that point of time the first process is come. So I place in my Gantt chart the first process. Then the total burst time for the first process is 5. So within 1 second, means 0 to 1 second, if I calculate how much process is done, that is 5 minus 1 equal to 4. Let's now see that we after 1 second another process is come, that is process 2. Whenever the process 2 is come, now look at the burst time of process 2, it is 3, and the remaining burst time for process 1 is 4. So which process is smaller, 3 or 4? 3 is smaller. That's why I suspend the tasks of process 1 and move to process 2. Again within 1 second means 1 plus 1 equal to 2 seconds. After 2 seconds, you see the process 3 is come. But look at the burst time. The burst time of the process 3 is 4. Minus 1 from 3 plus 1 equal to 2. So the burst time of process 3 is 2 and process 1 is 4. So which is the smallest? Process 2 is actually smallest. So I complete the full task within. So 3 plus 1 equal to 4. So I complete the process 2 tasks. Now within 4 seconds another process is come, that is my process 4. Look at the arrival time. Now I have total three process in my hand. Process 4, process 3, process 1. Process 1 is my running state. Process 1 is my suspend state. Process 3 and process 4 are fresh. Now look at the burst time. Process 4 is 1. Process 3's burst time is 4. Process 1 burst time is remaining 4. So which is the most smallest? Process 4 is the most smallest. So now at first I will place the process 4. So 4 plus 1 equal to 5. Then come to process 1 and process 3. Both of them now total burst time is 4. Now who is pending? Process 1 is actually pending. Suspend. So now I will take my process 1 and calculate 4 plus 5 equal to 9, and then I place my process 3 and calculate 4 plus 9 equal to 13. So now check the completing time. Process 3's completing time is 13. For checking the completing time for this primitive scheduling, you always start to check from your right hand side. Then check the process 1 completing time, that is 9. Then process 4 completing time, that is 5. Then process 2 completing time, that is 4. Guys, do you clear or confusion? Tell me.
No, ma'am. No confusion.
Okay. Now tell me, I will tell you the difference between shortest time remaining and short job fast. Short job next or short job fast scheduling. What is the difference? You see, this is also go for the priority according to the smallest bus time, and that is also give the highest priority to the smallest bus time. But the difference is whenever you think about the shortest job next, it does not suspend any task or any process. It just do the process whenever it take a process that is most smallest within the time. If another process is come and that new process bus time is more smaller than the running process, it does not care for it. It does not stop the current process. It at first complete the current process, then it go for the next process according to the bus time. But whenever it comes for about the shortest remaining time scheduling, at that time it actually always check about not only the smallest bus time but also within 1 second gap. It always check whether any new processes come or not. If any new processes come, whether the bus time is smallest or not. If the bus time is smallest, at that point of time it stop the execution of the current process of the new process. That is, you need to always remember between the first come short job next scheduling and shortest remaining time scheduling. Do you clear, guys, or confusion?
Clear, ma'am.
Yes, ma'am.
Okay. Now look at this exercise. The most important thing is to find out the completing time. So first of all, look, there are total 4 processes. At first, create the Gantt chart for your process. Look, when the 0 second arrival, the first process already come. So at first I place 0 to 1. My first process is come, that is my process 1. Now check the burst time. Total burst time is 7. Within 1 second, any process is come, guys? No. Within 1 second, no new process is come. So within 1 second, no process is come. So I can continue the task within 2. So I continue within 2. After 2, you see another process is come. That is my process 2. Now 2 tasks is done. That is, so how many tasks will be left? 7 minus 2 equal to 5. 5 tasks is remain for my process 1. Now process 2 come at 2 seconds. Burst time of process 2 is what? 4. So I will go for my process 2. When I go here in process 2, if I calculate 1 second to 2 plus 1 equal to 3. So within 6 seconds, no job is arrive. Now 2 plus 2 equal to 4. So within 4 seconds, another job is arrived, that is process 3. Now look at the past time. So if I minus that 4, minus 2 equal to remaining 4. Remaining 2. For my process 2 remaining 2 process. Now look at process 3. Within 4 seconds, 3 is come. Look at the burst time. Burst time is 1. That means its burst time is 5, its remaining burst time 2. And its total burst time is 1. So the most smallest is now process 3. So I will place my process 3 in here. And 4 plus 1 equal to 5. So within 5 seconds, my process 5 is done. Now within 5 seconds, you see another process is come, that is my process 4. When this process come, now look at the burst time. This process burst time is 4. Process 2 remaining burst time is 2. Process 5 remaining burst time is 5. Now which is the most smallest? Process 2. So now I will place my process 2. So 2 plus 5 equal to 7. So process 2 is also done. Process 2 done, process 3 done. Now remaining process 4 and process 1. Now look, process 1 is waiting and process 2 is just new coming. But the burst time of process 4 is smaller than process 1. This is 4, this is 5. 4 is smaller than 5. So I will place my process 4 in here and complete the full task. That is 7 plus 4 equal to 11. After that, I will place my process 1 and 5 plus 11 equal to what? 16. So the completing time of process 1 is 16. The completing time of process 2 is 7. The completing time of process 3 is 5. The completing time of process 4 is 11. Guys, do you clear or confusion? Tell me.
Ma'am, can you please repeat the addition? How can 4 and 4 is 11?
The remaining of process 1 is 5. So, the previous completing time, that is 11, and the waiting how much work is not complete, that is 5. The remaining burst time. So 11 plus 5 equal to what? 16. So by this way, do you clear or confusion?
Yes, ma'am, clear.
Okay. Any more question?
No, ma'am.
Now, this chapter last algorithm is round robin scheduling algorithm. So in round robin scheduling algorithm, it is always take up time quantum. Time quantum means always there is a time boundary that for each of the process it have that limited time boundary. Whenever any process come, each of the process you definitely have to complete within 2 seconds or within 3 seconds or within 5 seconds. That is actually called the time quantum. This is also this is also primitive scheduling, and in round robin scheduling there also suspension occur. You see the previous algorithm, that is remaining shortest remaining time, that is also suspends their work, and whenever you come for the robin scheduling it is also suspend the current process. So both of these scheduling you have to definitely understand in which point you have to suspend your process. And actually our round robin scheduling is the most popular CPU algorithm. It is most popular because I told you that whenever the processor do any task, for each of the tasks, it always hold a specific time boundary. That first process will complete within 1 second. Second process must have to complete within 1 second. For each of the process, there is always minimum time boundary. Whenever there is a minimum time boundary, at that point of time, you definitely need the round robin scheduling. You see, in the previous algorithm, there is not time boundary. It is always checked for the shortest work, the shortest possible work. Within the time, if it is found any shortest work, burst time is the most shortest, most smallest, it stop the current work and go for the shortest work. But in the round robin scheduling, it does not check that which work is the most smallest or which work is the most biggest. It always work according to the time. Now, let me at first build the mathematical problem for you. Then I will discuss it. Okay. Now you see, I didn't give the arrival time. As I did not give the arrival time, you don't need to think about the arrival time. Let's think this is the question. I give three process. The burst time is 50, 90, 150. And the time quantum is 40. So within 40 seconds, if the process 1 cannot complete its full task, it will move for the second task. So first of all, according to the process number I take. So first I take process 1. Total burst time is 50 and time quantum is 40. So 50 minus 40 equal to what? So 10 seconds is actually remaining for process. It suspend now and go for now process 2. Whenever it go to process 2, total burst time is 90 and my time quantum is 40. So 90 minus 40 equal to 50. So 50 second is remaining for my process 2. Then after 40 seconds I move to my process 3. Whenever I move to my process 3, look at the total burst time. It is 150 and time quantum is 40. So I minus 150 minus 40 equal to remaining 110. So process 3 is also remaining 110. Now again I go back to my process 1. This is for my process 1. This is for my process 2. This is for my process 3. Now again I go back to process 1. Remaining time is 10 and time quantum is 40. But within 10 the work is done. After that, look at the process after process 1 is complete. My process 1 is complete. Then it go to process 2. So time quantum is 40 and remaining is 50. So 50 minus 40 again, that is remaining 10. So process 2 is not done, it remaining 10. Now it go for process 3. So remaining is 110, time quantum is 40. So 110 minus 40 equal to remaining is 70. Then my process 1 is done. Now again I go to my process 2. Whenever I go to my process 2, time quantum 14, remaining time is 10. So 10 plus 2, 10 equal to now again I go to my process 3 and look at the process 3. The time quantum is 40 and remaining is 70. So 70 minus 40 equal to 30. And again I go to process 3 because there is no more process left. So I actually does not change in the Gantt chart in process 3. And I directly calculate the 70 with 220. That means 290. Now, for the completing time, always you check the completing time from your right hand side, not the left hand side. So first the process 3. So the completing time of process 3 is 290. Then in the process 2, the completing time is 210. Sorry, the completing time of process 2 is 220. And now for the process 1. The completing time of the process 1 is 120. So by this way, you will calculate your round robin scheduling mathematical problem. Guys, do you clear or confusion? Tell me.
Clear, ma'am.
Okay. This problem is when if I not give you any arrival time. So this is actually much easier. But if I give you the arrival time, at that time you will face some confusion. So you see, here is the arrival time I have given and the quantum time is 2. Now how you will calculate? Let's see this, solve this math. Okay. Now in this problem, you see there are total 6 processes. Time quantum is 2 and I also put the arrival time. As I put the arrival time, so you see the first process, that is my process 1. First my process 1 is come. So at first I place process 1. Burst time is 4. So after 2 seconds, 4 minus 2 equal to 2. 2 work is will remain for process 1. Then you see within 1 second the process 2 is come. So I move for my process 2. Now look at the total burst time of process 2. That is 5. So 5 minus time quantum is 2 equal to 3. So 3 tasks is remaining for my process 2. Now look at the process 3. Whenever the process 3 is come, within 2 seconds the process 3 is come and the burst time of process 3 is 2. So 2 minus 2 equal to what? 0. So actually my process 3 is done. No task is remaining. At first my process 1 come. Now check in here that process 3 is done and within 6 seconds already my process 4, process 5 and process 6 also come. And my process 1 and process 2 are actually waiting. These two are waiting and these two are just newly come. So that's why I again go to my process 1 because my process 1 and process 2 are waiting. And the lowest and the earliest coming process is my process 1, not my process 2. Again I go for process 1 and the remaining terms of process 1 is 2. So 2 minus 2 equal to 0. So I will place here my process 1 and it 8. Now look at the process 2, process 4, 5 and 6. Now look at the burst time of each of them. Process 2 remaining burst time is 3. Is remaining burst time is 3. Process 2. Process 4 is 1. Process 5, 6. Process 6, 3. Now which is the shortest burst time? Process 4. Process 4 is the shortest burst time. So after P1, I will take the process 4 because it is the shortest burst time. So I take P4 and the burst time of P4 is 1. So 8 plus 1 equal to 9. As quantum time is 2, but the burst time is smaller than quantum time. So process 4 is actually just a second, it is just done. So process 4 is also complete. Now let's see. Process 1 is waiting. Process 2 is waiting. Remaining burst time is 3. Process 5, total burst time is 6. Process 6, total burst time is 3. So two processes have the same burst time. Process 2 and process 6. Both are in waiting. Process 2 is waiting state and process 6 is the new, that is in the ready state. So I will take the waiting state process first. So that's why I will take my process 2 in here. Process 2 and total remaining time is 3 and my time quantum is 2. So 1, it cannot be finished. 1 is also remaining. So it will be again 9 plus 2 equal to 11. Now between process 4 and process 6, process 4, process 5, process 6, process 5 come earlier, then come process 6. So that's why at first I take process 5. As time of process 5, 6 minus time quantum equal to 4 tasks will be remain for process 5. So I will place process 5 in here. Then I will go for process 6. I go for process 6 and burst time is 2 for 3 for process 6 and time quantum is 2. Guys, just give me 1 second. Okay, guys. So then I take process 6. So burst time of process 6 is 2, 3, time quantum is 2. So 3 minus 2 is 1. So when I go for process 6, so 13 plus 2 equal to 15. Now, which process are remaining? My process 6 is remaining, process 5 is remaining, and process 2 is also remaining. Look at the burst time, remaining burst time. Process 5 remaining burst time is the highest. Process 2 and process 6 are same remaining burst time, but process 2 is waiting for the longer time than the process 6. So that's why I will again take process 2. One is remaining, so does not anything is not remaining. So I will take here process 2. So 15 plus 1 equal to 16. Process 2 is also done. Now between the process 5 and process 6. So between process 5 and process 6, the burst time is small is process 6. So I will take again the process 6. So for time quantum 2 and remaining time is 1. So within once again it just complete its tasks. So process 6 is also done. So 16 plus 1 equal to 17. Now only one process is left. That is my process 5. So in process 5, how many the time is left? That is 4. 4 is left. So as there is no process is left, so for that reason, I will just take process 5 in here. And so 4 plus 17 equal to 21. So process 5 is done within 21. Guys, do you clear this math, or do you have any confusion? Guys, the same math is given in the slide, but in the slide, it has some mathematical calculation is wrong. So don't follow this slide. Follow the mathematical calculation which I have done in here. You just need to understand it. Guys, do you clear or confusion? Tell me.
Ma'am,
Yes, tell me.
ma'am, I said we are clear, ma'am.
Okay, so if you are clear, so that's very good. Because you have to clear understanding about this four algorithm. Because in the final exam, I will give these four types of algorithm to solve the mathematical problem. If you can at least find out the completing time, at that point you easily can find out the turnaround time, then the waiting time. And you will get the 100 out of 100 in your copy, written mark. But if you somehow calculate mistake in the completing time, at that point of time, your number will be decreased because your turnaround time and waiting time both are actually depend on your completing time. So if you are clear, all of you, so that's very good. And in the exam, I will give the four types of algorithm, mathematical solution. And important announcement that your oral exam date and time is changed, not too much changed, a little bit changed, which I upload in the Google Classroom. So all of you must have to check your oral exam date and time. And another important thing is 19th August is your written exam. So after submit your copy to the mail that I given you in the question paper. Don't need to call me that ma'am, do you get my copy or not? At first I will check that whether all of you give me you submit your copy or not. The students which I did not get the copy within the time, I will give the notice in the Facebook group that this student's copy I didn't get. So you don't need to worry about your copy that whether I get the copy or not. Do clear, guys?
Yes, ma'am.
Yes, ma'am.
Guys, can you see the attendance screen?
Yes, ma'am.
Yes,
Yes, ma'am.
Okay, serial 1,
Yes, ma'am.
2, 3,
Yes, ma'am.
4,
Present, ma'am.
serial 5,
Yes, ma'am.
6,
Yes, ma'am.
7, 8,
Present, miss.
9,
Yes, ma'am.
10,
Present, ma'am.
11,
Yes, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14,
Yes, ma'am.
Yes, ma'am.
16,
Yes, ma'am.
17,
Yes, ma'am.
18,
Present, ma'am.
19,
Yes, ma'am.
20,
Present, ma'am.
21,
Yes, ma'am.
22,
Present, ma'am.
23,
Yes, ma'am.
24, 25,
Yes, ma'am.
26,
Yes, ma'am.
27, 28,
Present, ma'am.
29,
Present, ma'am.
30, 31,
Present, ma'am.
32,
Present, please.
33,
Present, ma'am.
34.
Ma'am,
Yes, ma'am. Yes, ma'am.
Okay, 35,
Yes, ma'am.
36, 37,
Yes, ma'am.
38,
Present, ma'am.
39,
Yes, ma'am.
40, 41,
Yes, ma'am.
42,
Yes, miss.
43,
Yes, ma'am.
44,
Present, ma'am.
45, 46,
Yes, ma'am.
47,
Yes, ma'am.
48,
Yes, ma'am.
48, present or absent?
Yes, ma'am. Present.
Okay, 49,
Present, ma'am.
50. Okay, guys, any more left? What is your serial? Okay. Any more? Okay, guys. So thank you. You can leave the classroom. Thank you, guys.
Thank you, ma'am. Assalamu alaikum, ma'am.